All right, Algebra 2, here's our second lesson. This one is on rational function graphs, number 2. All right, now the very first problem I noticed was kind of the exact same problem we had on the original lesson 1, and that's because we're using the same parent function. So I went ahead and inputted the values. If you need help with that, go back to lesson 1, where our graphs 1. And what we just ended up doing is just substituting each value in. So for this -5, that's going to equal x. So you're going to have 1 divided by -5, and that's where the -1/5 came from. All right, now with those values already in place, I also know that I cannot divide by 0, so that's actually going to be my vertical asymptote, which I'm going to go ahead and identify right here as my vertical asymptote. See if I can silence that so it doesn't play those chimes anymore. All right. And my vertical asymptote is going to be x equals 0. Now I do have a horizontal asymptote because I don't have a constant here. The constant is 0. So that horizontal asymptote where the values are not going to touch is going to equal y equals 0. Okay, so let's go ahead and go back to red and plot some of these points. So we're going to end up with -5 as our lowest x value. So I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 in that direction. And my highest y value is going to actually be 4 and -4. 1, 2, 3, 4. 1, 2, 3, 4. All right, so I'm going to pause here and go ahead and plot these graphs, and I'll be back in a moment. All right, so I went ahead and changed the color. I turned to black for the actual graphs themselves, the points. And let's go ahead and take a look at the domain and range. Now, I know it says interval and inequality, interval, and set. We were going to have you practice that, but let's just go ahead and talk about it being all real numbers except for when x equals 0, because x cannot equal 0 when we're talking about domain. Now, for range, it's all real numbers except y does not equal 0. Okay? Now, a place where the graph stops and starts over again is called a discontinuity, and you'll see that more in calculus and pre-calculus, just kind of exposing you to that terminology now. Now, if the graph shoots off to infinity, discontinuity is called an asymptote. If the graph just stops and starts again, and we're going to talk about that, well, let me do another graph here, and it's going to kind of start and then stop, kind of leaving a hole. That's going to be our removable discontinuity. That's our hole. And we're going to talk about what that looks like because we've only talked about what asymptotes and discontinuities look like. Okay, so that's going to be our first question here is for example 1. We're going to go ahead and talk about, notice how this one is different than what we're used to as far as y equals 1 divided by x. This one actually has a trinomial in the denominator and a binomial up in the numerator. So the first step that you're going to do here is you're going to go ahead and factor. So factor the denominator out. So I'm going to write down to x squared minus x minus 6, and we're going to go ahead and factor it. Okay, now I'm going to use the AC method. Now a is 1, so I don't even have to write down the AC method. It's just going to be -6, and I'm going to see the factors that add up to give me -1. And that's going to end up being -3 and +2. All right, now those are the two solutions. So if I were to rewrite this, that would be x plus 2 divided by x minus 3 in parentheses and x plus 2. So we actually have 2 points on this graph that we're going to end up having 0 as our solution for the denominator. Now the reason why we can say one or the other is because if I have this as 0, it would be 0 times x plus 2, and it doesn't matter what value I have here, it will make the entire denominator 0, and we know mathematically we can't do that. It's a big math. No, big black hole, don't do it, it's undefined. Okay, so what we need to do is we need to go ahead and, where it is x plus 2 and x plus 2, let's go ahead and simplify that out, and now we have a simplified equation of 1 divided by x minus 3. Now this is going to be our asymptote, our vertical asymptote, because it's going to shift right 3. 1, 2, 3. So we're going to have our vertical asymptote at +3. Okay, now we also have a hole because we were able to remove this discontinuity. Our hole is going to be at x is -2. If we were to set that equal, whoops, sorry, I'm jumping ahead of myself. X plus 2 is the factor that would be in the denominator. If that equals 0, then we need to see what x value it would we substitute into that binomial that would make that binomial 0. In this case, we would solve it, and that would just be x is -2. And that's why I already put the x value here, and we can actually find the y value by substituting it into the simplified simplified equation down here. So 1 divided by -2 minus 3, which would just equal 1 divided by -1/5. So that would be our whole. I seriously need to change color. I'm sorry, guys. I'm sorry because that's not different colors. Okay. Now let's go ahead and take a look at taking the simplified function of y equals 1 divided by x minus 3. Notice how that's a lot easier to deal with than simplifying it into this function. So we're going to substitute these values into this, and we're going to go ahead and track what's going on. Now there isn't a constant on the end, so we can go ahead and the horizontal asymptote is going to be right at y equals 0, so we can go ahead and fill that in. So let's go ahead and substitute some values in. Now I'm not always going to write down the math. I'm going to substitute it in. The first one we're going to substitute in together. So 1 divided by -4 minus 3, and that's going to simplify just to 1/7, -1/7. Next one is going to end up being -3. -3 in the denominator becomes -6, and then we are going to end up with -1/6. Next one, -2, that's just going to be -1/5. Next one is -1, so that's going to end up being -1/4. And then we're going to substitute 0 in. So that's going to become 1 divided by 0 minus 3, which is just -1/3. And then we're going to end up with 1. 1 minus 3 is just going to give you 1. Whoops, I don't like that format. It's going to be -1/2. Okay, then we're going to end up with 2. 2 minus 3 is going to give you -1. -1, or 1 divided by -1 just gives me -1. And we're going to have 3. This is interesting. So it's going to be 1, 3 minus 3, which just becomes 1 divided by 0, which, remember, that's our undefined. We cannot have, and that's why we have our asymptote right here at x equals 3, because it's an undefined line. Okay. 4. So then we're going to end up with 4 minus 3. 4 minus 3 is just 1. 1 divided by 1 is just 1. 5. 5 minus 3 is 2. So that's just 1/2. And 6. So then we would end up with 6 divided by 3. I'm sorry, 6 minus 3, which is 3. So that would be 1/3. And we end up with 7 minus 3, which is 1/4. Okay, so I'm going to pause the video and go ahead and graph these points. Alright, now welcome back. You will notice that all of this looks completely different. Yep, I messed up and couldn't figure out how to get it back, so I had to redo it. Now I also noticed that I made a mistake when I was telling you about -2. -2, we already determined that there was a hole there, and we already found that it was going to end up being -2 and then 1/7 or something like that, and we're going to go ahead and find that by plugging it back in. So we would end, not 7th, sorry, it'd be 1/5, -1/5. And that would be where we would have a hole. Now, as this graph is approaching, we cannot count that value. So we would state for the domain, it would be all real numbers, except x cannot equal -2, or this would be +3. Okay, and then our range would be the same idea, except we need to take in consideration this y value because it's also going to be an open spot. So range would be all real numbers except for when y is negative 1/5 and 3. So that would be not 3, sorry, negative 1/5 and when y equals 0. Alright, let's go ahead and take a look at example number 2. Now, I deleted this from your notes. We did not use the Rady cheat sheet that I had for last year. So what we're going to take a look at is the first step is we're going to go ahead and factor the denominator. And I also noticed that the numerator needs to be factored as well because it's a different of squares. So with your first step, let's go ahead and take care of that. Okay, so in the numerator, I can factor this, and I need to make that smaller. Dun, dun, dun. Okay, this is going to end up being x plus 1 and x minus 1, all divided by, and then when I factor this out, we could use the AC method, but in this way, a is 1, so we can go ahead and see what the factors of negative 3 are that add up to give me positive 2. So those factors would be 3, and I need one of them to be negative, but that one has to stay positive because I have a middle term that's positive. Alright, so looking at this, I noticed something. I noticed that we have x minus 1 and x minus 1 in the numerator and in the denominator, so that's going to be part of my whole. So the removable discontinuities that we can take care of, sorry about that, is when, because we have x minus 1 in the numerator and the denominator, so we can set that equal to 0, and that would just give us x equals 1. Okay, now that's not a point or an ordered pair, so we need to go ahead and set that in an ordered pair. So x equals 1, we need to substitute it back in to see what our y value would be, and so we can go ahead and do that in our original function. So it would be 1, wait, I'm sorry, not our original function, but our simplified function. So we would end up with 1 plus 1, which is 2 in the numerator, and 1 plus 3, which would be 4. So that would be 2/4, which is just 1/2. So our whole is going to be at 1, negative 1. So we will draw our graph. I will probably forget about this whole and come back and tell you I forgot, but we'll see. Hopefully, because I said that it didn't work, it didn't happen. Now I notice we have a wonderful box that says factor the numerator and the denominator. We did that up here, so I'm just going to draw a line for time's sake. When we're looking at asymptotes, asymptotes are only what is remaining in the numerator and then in the denominator. Okay. Now for our vertical asymptote, we are for vertical asymptotes, we are going to have to look at the denominator, and that's going to be x plus 3, and set that equal to 0. Oh my goodness, it's a horrible 0. And then we're going to subtract 3 to the other side. So we would end up with x equals negative 3. Okay, now I didn't really go over vertical or horizontal asymptotes very well, except for the fact that when you do have 1 divided by x, you would end up having whatever the coefficient or the constant is on the outside. That would be your asymptote, and then other than that, it would either be up or down from there. But in this case, because we have x values in the numerator and in the denominator, it actually is going to change. Now, we have x plus 1 divided by x plus 3, and they're going to be both to the power or the degree first power. So when that happens, it's a special situation when those powers are above each other, and this would be a lesson in itself, so I totally apologize. We would end up having our horizontal asymptote at y equals 1. Okay, so that's going to shift our graph up 1. Alright,